Hi, ninth period. Sorry I'm not here today, but I'm going to do the recording, so hopefully everything goes well. And you have a warm-up, so open up to page 29 in your note packet and do number 5. I'm going to start right away. So you read the problem. You see you have a perimeter and area information. So here's my garden, and it's length and width. And I know perimeter is 2 times the width plus 2 times the length equals 68. And I also know that length times width is the area, which is 240. So I have an equation of two unknowns, a system of equations with two unknowns. So that means I have to use substitution or elimination. Because of this multiplication here, I have to use substitution. It would be easier to get W or L alone in the first equation. But in first period, we decide to get L alone in the second equation. And it made the problem harder, so I wanted to show it to you. So here we have length equals 240 divided by L. I'm now going to substitute this in for L. So let me move down here. I have 2W plus 2 times 240 divided by W equals 68. I'm going to multiply the 2, so 2W plus 480 divided by W equals 68. And at this point, you might be thinking, well, I've never seen a W in the denominator. I don't know what to do. So think for a second. You can pause it if you want, but the easiest thing to do is to multiply both sides by W. So now I distribute, and I have 2W squared plus 480 equals 68W. Now you see I have a quadratic. Notice that I have a W squared term and a W term, which means I'm going to have to factor. I can't use square roots. So subtract 68W from both sides. 2W squared minus 68W plus 480 equals 0. Notice I have a common factor of 2, which I'm going to divide out because I have an equation. So W squared minus 34W plus 240 equals 0. Now I can factor. I want two numbers that multiply to 240, add up to negative 34. Because A is 1, this is pretty easy. If you can't think of it, remember, go to your graphing calculator and figure it out. But it's negative 10 and negative 24. Zero product property. And I discovered that W can be either 10 or 24. Now that's the width, right? But go back to the problem and think about what width and length are about here. If the width is 10, then that would mean that the length times 10 equals 240. So the length would have to be 24. If the width is 24, well, length times 24 equals 240. Then the length, the width, the length is 10. So it doesn't actually matter which one's the length and which is the width. It's 10 and 24 for either the length or the width. All right. Here are your homework answers. Why don't you hit pause so you can take a look at them a little longer. I want to go over number 3. So hit pause if you haven't already. So for number 3, I hope you're not sitting there complaining, oh, we didn't know what the area of a trapezoid is. You have so much technology at your fingertips. Look it up. You also could have found it, I believe, in your organizer. It's listed. Or maybe you remembered it from years past. That would have been really nice. All right, so it says one base of a trapezoid is 3 times the length of the second base. The height of the trapezoid is 2 inches smaller than the second base. If the area of the trapezoid is 30 inches squared, find the lengths of the bases and the height of the trapezoid. So I know either from looking it up or remembering that area of a trapezoid is 1/2 times the height times base 1 plus base 2. So let's set up some let statements here. So notice everything's based on the second base. So let x equal the second base. Let 3x equal the first base. And let x minus 2 equal the height. And now I'm just going to plug everything in. I know my area is 30 inches, 1/2 times the height. Now, what do you think I have to put around the height? Hopefully you're saying parentheses, yes. Okay. Now this 1/2 out in front, I don't know about you, but it's kind of annoying because I'm eventually going to have to distribute it. One way to get rid of it right away so I don't have to worry about it is just multiply both sides of the equation by 2. So 60 equals, and now I have x minus 2, and then notice I have x plus 3x. Well, that's just 4x. I'm not going to use my box. I'm just distributing a monomial times a binomial. So 60 equals 4x squared minus 8x. At this point, you should be thinking, am I going to square root or am I going to factor? Hopefully you say factor because of that middle term, that linear term. So subtract 60 from both sides. 0 equals 4x squared minus 8x minus 60. Greatest common factor is 4. Because it's just a constant, I can divide it out. A is 1. Two numbers that multiply to negative 15 add up to negative 2, negative 5 and positive 3. Zero product property gives me that x is either 5 or negative 3. Well, remember, my base is x. Can I have a negative base? Absolutely not. So I'm going to reject this. And that's how I get 5, 15, and 3. And that's in inches. Okay? If you have any other questions, I can answer them tomorrow, or you can help each other and go from there. So what are we doing today? We are going to learn about quadratic functions, specifically the symmetry that goes along with them, along with some other key functions, or excuse me, key features. All right. So what I'm going to have you do to start is take out your note packets to page 30. If you want, you can pause if you want more time. And what I'm going to have you do is just read page 30 to yourself. So please pause the video. I don't know, 2-3 minutes, pause. I'm going to jump right in and start talking. Okay? All right, so this box that says graph vocabulary was probably a little confusing. Star it. I want you in the future to come back and read it again. It's going to make so much more sense after we do a bunch of these. But for now, it's going to be a little confusing. That's okay. Read it again in the future. All right? So what did all that say? What did it all mean? Well, essentially what I wanted you to get from that reading, let me move this up a little bit so you can see better. There we are. Quadratics make a shape called a parabola. It's this U-looking shape. It can either open up or it can open down. If it's opening up, that means that the leading coefficient A is positive. If it's opening down, that leading coefficient must be negative. And that's right here. So make a little note to yourself that this A, this leading coefficient, is going to tell you if it's going to smile or if it's going to frown. All right? This is called the axis of symmetry. So this line happens to be x equals 3. It's always x equals a number. This line is very important. It is the line that makes this half of the parabola symmetrical to the other side. The point down here is called the vertex. When A is positive, the vertex is a minimum. When A is negative, the vertex is a maximum. So in this example, my axis of symmetry is x equals -1. Other things to notice. From here to here, this parabola, this quadratic, is decreasing. So when x is less than 3, it's decreasing. But when x is greater than 3, it's increasing. and it never changes. This will increase and just keep on increasing. It's never going to stop. Okay? Down here, this is called the standard form of a quadratic. And C represents something. Hopefully you're saying y-intercept. So this vertex we just mentioned, it has another name. We can also call it the turning point. And when the parabola opens down like this, we call it concave down. And when it opens up, we call it concave up. So take a moment, think about all that. If you have any other questions, I'll answer them tomorrow, or you can talk to each other. So what you're now going to do on the next page. Oh, I don't like this page. So this is just showing some real life examples where you might see in architecture some quadratic functions. Notice they're all curves, they're all parabolas. We can skip that page. Okay, so using this idea of symmetry, I would like you to go on and fill in this right here. All right. And I'm going to fill it in quickly for you right now. So hit pause and then you can check your answers. So we have 0, 3, 1, 0, 2, -1, 3, 0, 4, 3, and 5, 8. Notice the symmetry. This right here is the vertex, and everything is symmetrical about the vertex. The axis of symmetry is x equals 2. And just to note, that is not part of the graph. That is an imaginary line that we know the parabola is symmetrical about. Notice the y-intercept is 3, and there it is on the table. The x-intercepts are 1 and 3, and look, there they are. When x is 1, the y-intercept's 0. Excuse me, the y-coordinate is 0. When x is 3, the y-coordinate is 0. So those are your x-intercepts 1 and 3. Down below here, we have another one. Oh, I forgot to mention, A for this one must be positive because it's opening up. Where for B, A is negative. It's less than 0 because it's opening downwards. So let's fill in this one. If you haven't already, hit pause. If not, here I go. Notice once again the symmetry. Here is your vertex. Everything's symmetrical about it. Here is your axis of symmetry. X equals -2. X-intercepts are -4 and 0. So there they are, right there and there. All right. So this is sort of annoying, but on the next page, you're going to fill in information about graph A and graph B. And you have to flip back and forth. So one way to not flip back and forth is to simply leave my screen maybe like this so that you can see a lot of it. Okay, that way you don't have to flip back and forth. At least as much. So if you want to leave my screen like that, go ahead. Hit pause. I'm going to fill in the answers on the next page. So please hit pause before I start. All right, so you should have had x-intercepts of 1 and 3. The vertex is 2, -1. Please put parentheses around it. The leading coefficient must be positive, so A is greater than 0. The vertex is a min. It's a low point. Because of symmetry, these both have 8 as f of -1 and f of 5. Their y-coordinate is 8. And then is f of 7 greater or less than 8? It must be greater. Whoops, sorry. It must be greater because this function's always increasing at that point. So speaking of always increasing, it's increasing when x is greater than 2, decreasing when x is less than 2. I also could write this as from 2 to infinity it increases, and from negative infinity to 2 it decreases. Okay. The average rate of change, we haven't done this in a while. Oh, we did a little bit last, last unit we did a little bit. But remember, average rate of change is a change in y over a change in x. I know this is the same as the slope formula, but do you say slope when you're talking about something that's nonlinear? Absolutely not. So no mentioning slope here. This is just average rate of change. So I'm going to do -1 to 0. So when x is -1, I figure out the value of the function, and I'm going to subtract it from the value of the function when x is 0. So you could flip back, and you should see that when x is -1, y is 8. When x is 0, y is 3. So 5 divided by -1 is -5. You probably didn't have time to go through all of these, but here are all the answers in case you were speedy. All right, and we can do more of that tomorrow if you'd like. All right, the other side. X-intercepts. We've got -4 and 0. -2, 4 for the vertex. A is less than 0 because it's negative. It's a max. Because of symmetry, the answer is 3. I can predict f of -6 because of symmetry. When is this function increasing? It's increasing when x is less than -2, or you could say from negative infinity to -2. And it's decreasing when x is greater than -2, or you could say from -2 to negative infinity, or positive infinity. The average rate of change for these is 5, 3, 1, and 0. Notice the average rate of change started off really big at 5, and then it's getting smaller, 3, 1, and 0. That should make sense. Let's look back for a second. So at -5, I'm here, and at -4, I'm here. Look how steep this is. Whereas -4 to -3 isn't as steep. And then from -4 to -1, it's even less steep compared to this one. So as you continue along here, it gets less steep. And then once you hit the turning point, the vertex, it starts getting steeper again, but in a negative direction. All right. First period did not have time to do the last page of the notes. If you have time, go ahead and do it. If not, we will do this tomorrow. Okay? If you finish that and you still have more time, please start the homework. If not, just get done as much as you can. All right? Have a great rest of your day, and I will definitely see you all tomorrow. Bye.